Ghost voltage is a phenomenon that occurs when a voltage exists between a conductor and ground, even when the conductor is not connected to a power source. This can be caused by electromagnetic induction from nearby energized conductors or by the presence of stray capacitance. Electronic ballasts and fluorescent lights can be a source of ghost voltage. Electronic ballasts use high-frequency switching to regulate the current and voltage to the lamp, which can generate electromagnetic fields. These fields can induce voltages on nearby conductors. Ghost voltage can cause problems such as shocks to personnel, false readings on test equipment, and damage to electronic devices. While the level of ghost voltage is typically low, less than 50 volts, it can still be annoying or even dangerous. To address ghost voltage, several steps can be taken. Firstly, increase the distance between the ghost voltage source and the affected conductor. Secondly, use shielded conductors or metal raceways to reduce electromagnetic induction. Thirdly, install grounding devices to provide a path for stray currents. Fourthly, use isolating transformers to separate the ghost voltage source from the affected circuit. When a measurement of 46 volts alternating current is observed, this suggests that the ghost voltage is relatively high. It is a concern and should be addressed. It is recommended to increase the distance between the fluorescent lights and the metal-clad cable whips. Consider using shielded metal-clad cable whips or running the whips in metal raceways. Install grounding devices in the forks for junction boxes. Consider using isolating transformers to isolate the fluorescent lights from the rest of the electrical system. To ensure safety, it is important to have a qualified electrician inspect the installation and address any concerns regarding ghost voltage. The National Electrical Code, or NEC, provides guidance on grounding and bonding to minimize the effects of unwanted voltage. Article 250 covers grounding and bonding requirements. Section 250.4 discusses general requirements for grounding and bonding. Section 250.20 covers systems to be grounded. Section 250.24 provides requirements for grounding service supplied alternating current systems. Section 250.92 covers bonding of equipment containing over 250 volts to ground. Section 300.3 addresses the requirements for single conductors. Section 300.3 states that all conductors of the same circuit and were used, the grounded conductor and all equipment grounding conductors and bonding conductors shall be contained within the same raceway, auxiliary gutter, cable tray, cable bus assembly, cable armor, or cable sheath. Section 310.10 covers the uses permitted for conductors. Section 310.10H3 covers induced voltages. Where conductors of one or more alternating current circuits are installed in the same raceway, cable, or enclosure, the inductive reactance and capacitive reactance shall be taken into consideration. The requirements in 310.10(3) are followed to prevent dangerous voltage from being induced in the raceway, cable, or enclosure. NEC Table 310.16 provides ampacity ratings for conductors. These ratings are based on specific conditions, and adjustments may be necessary based on ambient temperature, the number of conductors in a raceway, and other factors. NEC Section 110.3b states that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. Electronic ballasts, like other electrical equipment, must be installed per their listing and labeling. Article 410 covers the requirements for luminaires, lamp holders, and lamps. Section 410.68 covers the support of luminaires. Section 410.69 covers the wiring of luminaires. When dealing with ghost voltage, several techniques can be employed to mitigate its effects. One approach is to use shielded wiring. Shielded cables have a conductive layer that surrounds the current-carrying conductors, which helps to block electromagnetic interference. By using shielded cables, the amount of ghost voltage induced on the conductors can be reduced. Another technique is to use metal conduit. Metal conduit acts as a barrier to electromagnetic fields, which can help to reduce the amount of ghost voltage induced in the conductors. When installing metal conduit, it is important to ensure that it is properly grounded. Grounding provides a path for any induced currents to flow back to the source, which can help to reduce the amount of ghost voltage present. Grounding is the process of connecting electrical equipment and systems to the earth. This provides a low impedance path for fault currents to flow back to the source, which helps to protect people and equipment from electrical shock. Bonding is the process of connecting different metal parts of an electrical system together. This helps to create a low impedance path for fault currents to flow, which can reduce the risk of electrical shock and fire. Another method is to use line filters. Line filters are devices that are designed to filter out unwanted noise and interference from the power line. By using line filters, the amount of ghost voltage present in the system can be reduced. Another method is to use isolating transformers. Isolating transformers are transformers that are designed to isolate the primary and secondary windings from each other. This helps to prevent ghost voltage from being transferred from one circuit to another. When working with electrical systems, it is important to use a properly calibrated meter. A meter that is not properly calibrated can give inaccurate readings, which can lead to incorrect diagnosis and treatment of electrical problems. When measuring voltage, it is important to use a meter that is designed to measure alternating current voltage. Direct current voltmeters will not give accurate readings when measuring alternating current voltage. When measuring voltage, it is important to connect the meter leads to the correct points in the circuit. The meter leads should be connected in parallel with the component or circuit that is being measured. Before working on any electrical equipment, it is important to de-energize the circuit. De-energizing the circuit will help to prevent electrical shock. When de-energizing a circuit, it is important to turn off the power at the circuit breaker or fuse box. After turning off the power, it is important to test the circuit to make sure that it is de-energized. A non-contact voltage tester can be used to test for voltage. When working with electrical equipment, it is important to wear appropriate personal protective equipment. Personal protective equipment can help to protect people from electrical shock, burns, and other injuries. Some common types of personal protective equipment include safety glasses, gloves, and insulated shoes. When working with electrical equipment, it is important to follow all safety procedures. Following safety procedures will help to prevent accidents and injuries. Before starting any work, it is important to read and understand the safety procedures. When working with electrical equipment, it is important to be aware of the potential hazards. Some common electrical hazards include electrical shock, burns, and arc flash. Electrical shock can occur when a person comes into contact with an energized conductor. Electrical burns can occur when a person comes into contact with a hot surface or an electrical arc. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. When working with electrical equipment, it is important to take steps to prevent these hazards. Always de-energize the circuit before working on any electrical equipment. Wear appropriate personal protective equipment. Follow all safety procedures. Be aware of the potential hazards. By following these steps, it is possible to work safely with electrical equipment. Consider the length of the metal-clad cable runs. Longer runs can act as antennas, picking up more induced voltage. Keep runs as short as practically possible. When routing the metal-clad cable, avoid running it parallel and in close proximity to other energized conductors for extended lengths. Maintain some physical separation. Ensure all connections within the forks for junction boxes are tight and properly made. Loose connections can exacerbate ghost voltage issues. Verify the grounding system is properly installed and connected throughout the warehouse. A robust grounding system could help dissipate induced voltages. If the issue persists despite other mitigation efforts, consider consulting with an electrical engineer to perform a more detailed analysis of the electrical system and recommend specific solutions. Electronic ballasts are more energy efficient compared to traditional magnetic ballasts. They offer features like dimming and better light output control. Electronic ballasts operate at high frequencies, typically in the range of 20 kHz to 60 kHz. This high-frequency operation is what can contribute to electromagnetic interference and ghost voltage. Shielding can be achieved by using metal conduit or specialized shielded cables. The shield acts as a Faraday cage, intercepting electromagnetic fields and preventing them from inducing voltages on the inner conductors. Proper grounding of the shield is crucial for its effectiveness. The grounding conductor provides a low impedance path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock. The size of the grounding conductor must be appropriate for the size of the circuit conductors, as specified in the National Electrical Code. Isolating transformers provide electrical isolation between circuits, preventing the transfer of noise and unwanted voltages. They are particularly useful in sensitive electronic equipment or where ground loops are a concern. When using isolating transformers, ensure they are properly sized for the load they are serving. The transformer's voltage and current ratings should match the requirements of the connected equipment. Consider power quality. Power quality refers to the characteristics of the electrical power supply, including voltage stability, harmonic distortion, and transient disturbances. Poor power quality can contribute to electrical problems, including ghost voltage. Power quality can be improved by using power conditioners or uninterruptible power supplies. When troubleshooting ghost voltage, use a high impedance voltmeter. High impedance voltmeters have a minimal impact on the circuit being measured, providing more accurate readings of ghost voltage. Low impedance voltmeters can load the circuit, causing the ghost voltage to disappear. Measure the voltage between the conductor and ground at various points along the circuit. This can help to identify the source of the ghost voltage. When ghost voltage is present, it is important to take steps to mitigate it. Failure to address ghost voltage can lead to electrical problems, including equipment malfunction and electrical shock. Proper planning and installation practices can minimize the risk of ghost voltage in electrical systems. During the design phase, consider the potential sources of electromagnetic interference and take steps to minimize their impact. Use shielded wiring, install metal conduit, and ensure proper grounding. During installation, follow all applicable codes and standards. Ensure that all connections are tight and properly made. After installation, test the system to verify that ghost voltage is within acceptable levels. If ghost voltage is present, take steps to mitigate it. When working with electrical systems, it is always best to err on the side of caution. If there is any doubt about the safety of a situation, consult with a qualified electrician. Regularly inspect electrical systems for signs of problems, including loose connections, damaged wiring, and corrosion. Address any problems promptly to prevent them from escalating into more serious issues.